Hello everyone, welcome to our class. I'm Professor Wilson Kamami and my YouTube channel is also called Professor Wilson Kamami. This is the channel that we always simplify mathematics together. Welcome. We look at our third video on set theory. We are still at the set theory. This is our third class where we are going to look at Venn diagram. And at the Venn diagram, we had introduced some few elements of Venn diagram. Let me take you back to some things we had looked at. We said, assume you have set A, which has 1, 2, 9, 7, 9, 6. And you assume you have set B, which has 3, 5, 6, and 7. And then we have our universal set. The set under consideration, maybe it is 1, 2, 3, 4, 5, 6, 7, and 8, and 9. So with this one, we said if you have to represent the above information at the Venn diagram, we said this is our universal set. We use rectangle to represent our Venn diagram. We use circle to represent the ordinary set. So this is universal set. These are ordinary set. We said this is a universal set. This is set A, and this is my set B. I said when we are drawing a Venn diagram, it is good you first name elements which are of intersection. And in this case, which element are in this one and in this one? I think it's only 1, 6. So the other elements in A are 1, 2, and 9. The other elements in B, apart from this one that is intersecting, is 3, 5, and 7. So that is the A. So whenever you are mentioning elements of A, you say 1, 2, 9, 6. When you are mentioning the elements of B, you will be 6, 3, 5, and 7. So those are elements in B. But you have those elements that are not in both A or B. They are not either in A or B. So based on our universal set, 1 is there, 2 is there, 3 is there. Here we have 4. We have 5, 6, and the other one is 8. So these are elements that are not either in A or in B. So those are 4 and 5. So this is how we represent our Venn diagram. Now, this was just the introduction part of how it is Venn diagram. But now I want us to look in the application part of Venn diagram. Because I want to give you a simple example. We solve one more example, and maybe I will leave a question there so that you can do. I will leave 2 questions there so that you can practice on how we solve Venn diagram. Let's take an example. You are in a school that you are enrolling students. And when you are enrolling students, you have 2 programs, maybe you are marketing. One is engineering, and the other one is biochem. So during your marketing, you go and meet around maybe 100 students. I'm just giving an example. You go to meet or you have enrolled 100 students. But when they are coming, you tell them to choose one of the 2 programs. Either engineering, maybe computer engineering, and the other one, they have to choose biochemical. You realize that the student choose engineering. That the student choose engineering. 25 students choose biochem. They choose biochem. And maybe both program, you find there are students who are, maybe they can say, I will take, they don't know, but they choose both program. You find that maybe both programs are chosen by 15 students. And then there are those students who are confused further, they don't choose any of the program. So you are told to represent the above information. I want to take this example. How many students are under consideration? Our universal set is a set of 100 students. That's our universal set, the set under consideration. But we have 2 programs, so we have 2 ordinary sets. We have those who choose engineering, maybe I can call it set E, and biochem, I call it set B. But you realize that there are those who chose the program, both programs. I said when you are drawing even a Venn diagram, I said you start with the intersection. So you realize those who chose engineering and biochem, they were 15. Those who choose somewhere biochem, either both or anywhere, you find they are 25. So it means that biochem had 25. So here we put what? 10. Because in general, it had 25 students who chose biochem. There are those who choose biochem only, and there are those who choose biochem and engineering. The one who chose only, they are 10. Those who chose with engineering are 15. But in general, how many? 25. Again, you have those engineering students, they are 30, but remember 15 combined with biochem. So those who chose alone, engineering alone, they are how many? 15. So that in general, we have 30 students. So I'm asking you, how many students did not choose any of the program? So remember, our set under consideration is 100. So we have 100. So here we don't know how many students who chose none of the two programs. So in this case, my x, we know x plus 15 plus 15 plus 10 should give you the total, our universal set under consideration. Remember 4 and 8 was the one that was adding up to our universal set. So in that case, you realize that your x is equals to what? Is it 60? Your x will be equals to 60. So 60 students, when you admitted them, they didn't choose any of the program. So that means that 60 didn't choose either engineering or biochem. So you realize that maybe 60 in one or the other in future, when you are doing analysis and explanation, you may find this one were preferring other program. So whenever you are making a decision, you can see a big number chose not to do either engineering or biochem. Maybe this one were preferring to do education, were preferring to do maybe the other public health or health sciences. So in that case, that's how we apply Venn diagram. That's a good example of a Venn diagram. Let's look at another example of a Venn diagram where we have 3 ordinary sets. Pause. On example 2, we look at another example where we have 3 ordinary sets so far. So let's take at the same example. You have admitted 200 students. 200 students were admitted at Iceberg University. Let's take an example. 200 students were admitted at Iceberg University. You realize that 40 students chose to do ICT. The other 50 or 60 chose to do medical sciences. Okay? There are those who chose to do engineering. There are those who chose to do engineering. Then you find that 15 chose to do engineering and medical. Or what I can also say 10 chose to do engineering and ICT. Okay? Maybe I could have added this one to be 45. 45 chose engineering. 15 chose engineering and science. 10 chose engineering and ICT. And you realize that now 20 chose medical science and ICT. 20 chose medical science and ICT. And 5 students chose all 3 programs. I want you to take that example. You have admitted a student. You realize when you are tallying on the number of students, you realize 40 chose ICT, 40 chose somewhere medical science, 45 chose somewhere engineering, 15 chose engineering and medical, engineering and ICT, and that one. So how do we draw this one? How do we represent this one in a diagram? What we call Venn diagram. when we draw Venn diagram, it will help us to determine those who chose this subject only, those who chose this program only, so that we can be able to make a decision. This is our universal set, and remember we are considering 200 students that we have admitted. So we have ICT, maybe I can use I. We have medical sciences, maybe I can use medical, and we have engineering. Don't mind my diagram. Don't mind them. So in this case, whenever you want to solve a Venn diagram, I always advise my student, look at where we have majority of intersection. And in this case, it is where we have all three. This intersection, where we have intersection of engineering, medical science, and ICT. So in this case, you start from where we have more intersection. So in this case, 5 students chose all 3 programs. So 5 chose all the 3 programs. You know it will be there. Then, as we are going up, then those who chose 2, medical science and ICT. Medical science and ICT had 20 students. So it means this intersection had 20. But already 5 chose 3. So it means those who chose this one are 15. I hope I'm clear. Those who chose medical science and ICT were 20. But 5 chose 3 programs. So you find that those who chose only this one and my medical only 2, you realize the one 15. Again, engineering and ICT had 10. Engineering and ICT had 10, but already 5 chose they had added another program, so this one becomes 5, so that the intersection of engineering and ICT will be 10. Again, engineering and medical sciences, you realize that engineering and medical sciences were 15, but 5 already had chosen even ICT, so you realize it will be 10. And this one simplifies our work easier because maybe they will ask you, those who chose engineering and medical science only 10, 2 of them, they chose 2 programs only, engineering and medical. Those who chose ICT and engineering, both 2 programs, 5. So now we go to engineering. Engineering had 45. So you look at engineering, those who chose engineering under this ordinary set, there were 45, but 5 are here, 5 are here, 5 are here. So you subtract 20, so you realize those who chose engineering only, they were 25. Medical science, you realize, had 60, but 10, 15, 5, those are 30, if I'm not wrong. So you realize those who chose medical science alone, they were 30. And maybe 40 ICT, you already subtract 25, you realize those who chose ICT only are 15. So whenever you are making your own decision, you can realize even though 40 students chose ICT, those who chose ICT only were only 15. My medical had 60, but those who chose only medical, they were 30. Those who chose maybe engineering, they were 45, but those who decided to stick with only one program, they are 25. So in that case, you can make a decision and say, out of these 45, 25 are clearly they want engineering. Maybe you can decide as a management on how you can deal with the other 20. Maybe you give them orientation or something like that. Now, remember, our set had how many students under consideration? 200. So there are those who chose none of the above program. So you calculate, you add everything, then you subtract from 200, you get your x. So your x plus 15, 15, then plus 30, plus 10, plus 25, this should give you 200. Now we are including everything so that you can see what will be the answer. I think that one will be 40, another 40, another, so you realize that it is 105, so x is equals to 95. So you realize out of this, the 200 students we admitted, 95 didn't choose any of the 3 programs. So you may say maybe the other one are preparing to do what? Business courses. So that's how we apply Venn diagram. Thank you for watching this video. This is our that video on how we apply Venn diagram. We have looked at various examples. There down I will leave I'll also leave a question, so that 2 questions so that you can practice. And I will leave a question where you have not been given this, all those who chose a 3 program. So it means that you have to assume that one is X. So here will be, if like this one was 10, engineering and ICT, you could have said this is 10. Now I'm assuming the other question, you have it is 10 minus X. We are assuming this one you don't know X. So this one again will be 15 minus X. You will do like that, and at the end of the day, you will solve for X. Remember, even here, maybe I will have given a 5 as those one who chose none of the 3 programs. Maybe 5 is those who never chose any of the program. Now I ask you, how many students chose all the 3 programs? So I'll give you that question. You practice, and I want to say thank you for watching. Continue sharing. I always advise students to share with their fellow colleagues concerning this channel so that we can continue simplifying mathematics together. At the same time, I always advise students to comment there below on maybe a topic that they will prefer us to tackle, maybe which is giving you challenges at the campus or at college level. So thank you very much for watching, and continue subscribing. Well, the next video on set theory, it will be more of pure, where you look at the rows of sets. We shall look at even De Morgan's law, and we maybe can prove 2 theorems, so that that one will be more of pure mathematics, how we prove some theorems and some in set theory. Thank you very much.